problem, but someone had the good wisdom to see that all chemical engineers don't approach problems the same way. So,
True.
yeah.
All right, well, we've got some folks still coming in, but we can go ahead and get started, I think. So, welcome everyone. Thank you for taking some time with us today. I'm going to ask that you all remain muted while Lyndon is speaking. And after he's done with his presentation, there'll be an opportunity to ask questions. When we get to that point, if you would just please raise your hand. And if you don't know how to do that, if you I think it should be visible to you right at the bottom of your screen, and we'll call on you. And at any point during the day, you can just type a question in the chat box if that's more comfortable for you, and we'll ask those questions during Q&A. So with that, I will let Linda begin, and Megan is going to share your slides.
All right. So good afternoon, everyone, and thanks for making time out to speak with me. Speaking in the context of my new role as the Dean of Cornell Engineering. Now, I've seen and spoken to some of you before in this role. And the goal of this meeting is really to just get to know you, for you to get to know me, to get to appreciate some of my early thoughts about the direction our college could take or should take as a potential opportunity for improving our impact. So before I get going, though, I want to just say a couple of words about myself. So I've been at Cornell now for 20 years. I was a professor in chemical engineering and was the director of the School of Chemical Engineering for a 10-year period beginning in 2010. I've had the good fortune as a faculty member, teacher of interacting with students, many are on the call today, across the 20-year period I've been here. So I've had that really interesting opportunity to see the great talent of the students we recruit to our programs, and to play some small role in developing this talent to maturity. Now, I have two children. In fact, both of them are Cornellians. My daughter completed her education in CALS about 2 years ago, and she's now in grad school. And my son is actually a junior in operations research here in the College of Engineering. So I also carry the perspective of the Cornell parent as well. My wife, who is also a chemical engineer, believe it or not, is a senior lecturer in biomedical engineering at Cornell. So I also have, again, that important perspective. So a good question that many of my friends have asked me is, why take on this difficult role in them at this particularly challenging time? And the answer I give them is really about history, that I didn't really aspire to this role. But as I've thought deeply about Cornell's history and thought about, in fact, what brought me here 20 years ago, I see this really nice connection to teaching and research, and an increasing role for doing that in a way that impacts diverse cohorts of students that is really inspiring to me. And so then again, as a faculty member, as a parent of Cornell children, as a spouse of a Cornell professor, I felt like, this is a good time, as any time, to have an impact on this important institution. So next slide. So what I want to do in the next few minutes, next slide, please. Yeah, what I want to do in the next few minutes is to begin a conversation. I mean, obviously, if we weren't living in the times we're in, I would be able to have this conversation with you in person and to do it in a slow, deliberate way where you get to ask me questions and I respond. But here we're going to do it in somewhat of a more structured way, where I'll tell you a little bit about what motivates me, what inspires me, what are some of the opportunities I see for us as a College of Engineering, what are some of the threats I see, what are some of the things that keep me up at night about our college's future. And I want to spend a little bit of time also talking about how are we going to address these threats, these weaknesses? How are we going to realize these opportunities? describing to you briefly a strategic planning exercise that is just underway in the college. And then towards the end, I'll tell you a little bit about some of the priorities related to fundraising, and hopefully, leave enough time so we can have a very nice, vigorous conversation with some questions and answers. Next slide, please. So let me begin at the beginning. So, I'm the type of person, I need to be inspired, and I work really hard. I'm quite driven, I'm quite creative, but I need to be inspired. And one of the things that just caught my attention is the fact that our college has been just tremendously influential in incubating leading ideas in education and research. And I thought, what if we were able to go the next step, right? We're always told that we're a land grant institution, and part of the responsibility of a land grant institution is to take our best ideas from the laboratory bench to have impact on the world. And so I thought, what if in 10 years' time our college had the ability to not only claim to be an influential institution in incubating ideas in education and research, but in translating those ideas into products that can impact the world? What if? And so that has been my inspiration. What are the steps that we need to get there? What are the challenges? What are the barriers? And I'm going to tell you a little bit about things as I see them. Next slide, please. So I think the first opportunity I see, frankly, as a college of engineering for achieving that grand aspiration has to do with people, has to do with nurturing and rewarding excellence, not just among our faculty, but our staff and our students. Recognizing people who are excellent is a pretty important way of cultivating a culture where excellence is prized and people who are actually overperforming feel like they belong. And I want to create that climate in our college by identifying our stars early and rewarding them for overperforming. Now, there's another opportunity, and that opportunity has to do with building strength at the intersection of the different disciplines that constitutes engineering. It used to be in the past that engineering would be well defined by the silos: civil engineering, chemical engineering, electrical engineering. But as time has evolved, it's becoming clear that the problems that we confront in society, the problems that we confront in technology, are actually system problems. Problems that require expertise in one discipline interacting with expertise in another. And I see a tremendous opportunity for bringing research stars that live at the intersection between the different disciplines in engineering to build our strength at the intersection between fields. So that is the second really big challenge I see as dean, but I think one that if we can be successful in meeting that challenge can be tremendously influential. I started this conversation by telling you that I was inspired to move to Cornell 20 years ago because we have this sort of reputation, and it's a big one, for being influential both in research and teaching. But one of the things that struck me is that as I looked around the college to see how were we rewarding persons who were excelling in teaching, I discovered that not as well as we were rewarding people who excelled in research. I want to change that. I want, in the first 5 years that I'm your dean, I want to ensure that at least one endowed chair, one teaching excellence chair resides in every single department. And my goal is that if we do that right, we will create a community of scholars who are as passionate about what they teach as about how they teach it and where it's taught. And I think having this cohort of people in our midst will sharpen us to become even more effective and influential in teaching engineering. Now, you've heard President Pollock talk about One Cornell and the opportunity bridging boundaries between the different fields in Cornell University represent for the university. I see an analogous opportunity in what I'm calling One Cornell Engineering, which is to unite engineering across the multiple fields. Many of you are aware that engineering doesn't only happen these days in the College of Engineering at Cornell. It happens in New York City at Cornell Tech. It happens at Weill Cornell College of Medicine. It happens in the CALS, the College of Agriculture and Life Sciences, I see the role of the Dean of Cornell Engineering as essentially providing the glue, providing win-win kind of opportunities for persons to collaborate across these boundaries to create a one Cornell environment that unifies us across engineering. Now, I'll talk a little bit more about our spaces. I think the bulk of the spaces in the college are functional but old. Many of the buildings that occupy the engineering quad were built in the 1950s and 1960s when the discipline of engineering was completely different than it is today. It was mechanical, it was big, it in fact was decidedly not biological, and almost never involved things that were molecular, or at least explicitly molecular. That has obviously changed, and it's a bit of a miracle to me that we were able to essentially sustain this new discipline in infrastructure that is largely outdated. I see a pretty tremendous opportunity for innovating our spaces one space at a time, building by building, and adding one new building to the engineering quad to round out our preparation to train the engineers of the next century. Now, one of the features of Cornell Engineering and Cornell, I would argue writ large, is this living laboratory concept, where the university treats itself as essentially a lab to test new ideas, important ideas. And in fact, I would argue we're living in one of those moments right now, where most of you have probably read about a tremendous experience Cornell has had in reintroducing fall semester instruction, in-person instruction this fall, the challenges around testing, contact tracing, using science, in particular data science, to guide those decision-making processes. And you've hopefully read and followed our dashboard to see the successes we're having. Engineers are front and center in this effort, and I think this is just spectacular for Cornell. Now, there are other opportunities on the horizon where I see engineering having a similar role in this living laboratory configuration, and they have to do with our climate. In particular, many of you know the university has embraced a so-called climate action plan that, among other things, says that by the year 2035, we want the campus to be carbon neutral. Engineers, again, are playing a crucial role, whether it's in earth source heat, whether it's in using hydrogen to store energy when we have plentiful supplies. And these are places where I think we can have impact as a college and we can be influential. Next slide, please. Now, I think fundamentally, influence is not just about opportunities, which I described in the last slide, but it's really about raw material. It's about, taking raw material that starts out being exciting and putting it into the world to have impact in the world. And I would argue that among our peer institutions, we've been spectacular at recruiting the very best of students. And so I started our undergrad population. It's not large, roughly 3,000 students, but remarkably, within that 3,000 students, we've become the most diverse engineering college probably in the country. The incoming freshman class is just remarkable in that regard. 51% of our incoming freshman class, and I should say our matriculating freshman class, they've already been here for almost a semester, are women. 24% are members from underrepresented minority groups in engineering. 14% are first generation students. And the remarkable statistic for me is that within that group, 95% of these students were in the top 10 of their high school graduating class. I think that is the way to have influence, to train an exceptional group of students that are not just exceptional because of their ability, but exceptional because they represent the broad diversity of our society. Now, one of the things that surprised me about our engineering undergraduate numbers is the statistic that is actually encapsulated in curly brackets towards the bottom left of my slide. And that is the BSW statistic, right? What that is saying is that a number of bachelor's degrees awarded to women students in engineering across the country, of every 100 degrees awarded each year, over 1.2 are Cornell degrees, right? We never think of ourselves that way. We are not small in terms of the number of students we're putting into the marketplace. And we're certainly not small in growing the diversity of that marketplace by matriculating and graduating quite diverse student populations. Though the impacts at the graduate level are even more spectacular and remarkable. Roughly 1.4 of every 100 PhDs awarded in the US every year is now a Cornell degree. That is surely a way that the College of Engineering can have influence by training these students to be the best at what they do. Among the faculty, we are also known for rigor, but we are also known to be understated. And one of the impacts of that is that we're not as recognized perhaps as we should be on the national scene. I want to change that. I want to reward excellence among our faculty by also nominating them for national awards, telling their stories better to the world, to ultimately, again, take advantage of this tremendous resource we've built in Cornell Engineering to have the impacts that I think we want to have as a college. Next slide, please. So look, the other element of having influence is to be working on problems that are relevant, problems that are grand challenge questions. And so what this chart attempts to show you are, on the left side, the areas where Cornell Engineering has invested, the areas where we're strong, we're historically strong: advanced materials, bioengineering, computing and data science, energy and the environment. And on the right side of this slide, it tells you the so-called National Academy of Engineering 21st Century Grand Challenge questions for engineering: affordable solar energy, energy from fusion, food, water, urban infrastructure, human health, and so on. And what the arrows show you is how well the strengths of Cornell overlay with the grand challenge questions identified by the National Academy. Now, granted, these grand challenges are a set among many, but the point I want to make is that if you overlay any set of grand challenges with our talents, you see this kind of beautiful intersection where our talents intersect many of the needs to solve these grand challenges. And I think that's a pretty important opportunity, because it says that we're not just tooled right to be influential, but also we have the opportunity perhaps to benefit from the sort of reflected waves, if you will, when we work on these problems, to learn what the real questions of society are and to ultimately tweak our disciplinary strength to solve those problems. So we don't just have the right tools, we don't have some good opportunities for improving the College of Engineering, but we also have made good investments over time that puts us, I think, in a bird's eye seat somewhat in terms of our ability to solve problems that are relevant and impactful in society and perhaps even in the world. Next slide, please. So what keeps a dean up at night? So what keeps a new dean up at night, right? So everything I've said so far sounds pretty good, pretty strong, and hopefully somewhat inspiring for Cornell Engineering. What keeps me up at night is, how do we become even better? How do we not just become better in our own eyes, but how do we become even better so that we're broadly recognized as influential? So here I'm showing you rankings, right? So many persons don't like to speak about rankings, but I do, because I think they provide a pretty interesting quantitative way of evaluating how we appear to the rest of the world. And so I show you two types of rankings. So on the left, these are rankings for the undergraduate program compiled by the US News and World Report. And on the right are rankings for the graduate program compiled by the same organization. Now, these rankings are developed in very different ways, right? So the undergrad ranking is strictly by surveys. So basically, the US News and World Report sends out a survey to deans of College of Engineering, and they would ask the dean to rate, say, Cornell Engineering on a scale of 1 to 5, rate MIT Engineering on a scale of 1 to 5, and so forth, and then basically accumulate these ratings to create what a rough GPA for each engineering college. And obviously the schools that have GPAs closest to 5 are ranked the highest, all right? So completely reputational. In that ranking, the College of Engineering, as you can see at Cornell, has been consistently ranked 9th or 10th, right? So in 2018, we were ranked 10th. In 2019, 9th, 2020, 9th. So we're steadily ranked just in the top 10 in that ranking based on reputation. Now, on the right, I mentioned these are the graduate rankings made by the same organization, but these are done in a very different way. 40% of the ranking to the right is reputational, again, accumulated in this same structure that I indicated before, a survey that leads to GPA, that leads to rank. But the remaining 60% is based on things like research activity, number of graduate students that you graduate, number of faculty members who receive prestigious national awards. And what keeps me up at night is the trend of these rankings, right? So the data points, the circles in blue, are the Cornell rankings over time. And what you will notice is that we're kind of going in the wrong direction, right? The blue rankings are getting worse with time, and they've gotten steadily worse over the last couple of decades. That is, of course, a problem. They started out in 1990, the first set of data indicated here, roughly sixth. So we were sixth in the country in terms of College of Engineering. 2020, the number is 14. So it's clearly not going in the right direction. Now, for comparison, I show you the analogous data, same ranking, for Cornell overall. And these are in the red squares. And you will see that that is also not going in the right direction, that as a university, we are also slipping in terms of our prestige in the world, in terms of how we are perceived to be impactful. Now, what worries me even more is that if you look at the slope of the blue line and the slope of the red line, you will notice the blue line is actually going in the wrong direction faster. So it indicates that we've got a lot of work to do. And remember, I told you at the beginning that 40% of the ranking on the right is reputational. But if you look at the results on the left, it says that's pretty steady. So it means that if 40% of something that is steady is not having an impact on this declining slope, it means the rest are actually becoming worse faster. And as a new dean, this is something that worries me a lot and something that I'm committed to taking action to correct. So I've set a goal that within the first 5 years I'm dean, I want to reverse this trend. I want to first stabilize this slide so that by the end of my first 5 years, I would like to be solidly in the top 10 on the ranking to the right. And my thought is that if the strategies that I implement as dean are successful in getting us there, we should be able to maybe speed up, accelerate, catalyze these effects so we can ultimately see a College of Engineering back to where it used to be in the 1990s. Solidly 6, 5, and perceived to be well regarded both in the undergrad reputational context as well as in this more quantitative graduate context. So a pretty tall order. So how are we going to do that? Next slide, please. Well, first of all, it requires infrastructure. It requires us to invest in infrastructure. And I already pointed out to you the downside of this, right? That our infrastructure is old. And I show you the example of the building that some of you probably were educated in, Olin Hall, which is the home of chemical engineering here in the engineering quad. And for those of you who don't know, Olin Hall was the first building built on the engineering quad. It was built in 1941. And I know this will surprise all of you. It was designed by the same architect that designed the Empire State Building. So you wouldn't notice it by just looking at it, but it is true. And I say that to say the building is old, but it has very good bones. It was designed well. And as evidence of that, I show you in the cutaway a renovation that my our current department head, Professor Abe Strook, was able to do in this old building using a $10 million investment from the Fleming family to transform this old building into the most modern space for doing molecular engineering within a chemical engineering department. So the point is that our infrastructure is old, but the bones are good. And I see tremendous opportunity, as I call it, for essentially building within this infrastructure the future of engineering infrastructure so we can, in fact, have an impact on research and teaching mission of our college. And next slide, please. So how do I kind of actionalize this plan? So I showed you one example in the context of infrastructure. But let me just speak more broadly to how we're going to do this. What is the strategy we're currently developing to get it done. So for those of you who don't know me, I'm a servant leader. I believe that the College of Engineering exists fundamentally to serve the departments. Why? Because departments are the places where students are taught, where curricula are developed, where research is done. And so I've challenged the faculty in our departments, challenged the leaders of our departments to implement what's called a bottom-up strategic plan, where the bottom-up strategic plan begins in the department. It begins with a quantitative assessment of how do we compare with the competition? Where do we stand? What are we doing that is world-class? What is not? What investment should we make to make the things that are world-class or have the potential to become world-class and quickly? And most importantly, what does success look like? What is success in achieving the goals of this plan, of achieving these investment opportunities? What does it look like for students? What does it look like for faculty? What does it look like for alumni? And the thought is that if we develop a plan based on those concepts, we will very quickly develop a set of priorities, and those priorities will drive a strategy that gets us to that grand aspiration that I began this presentation with. Now, my goals are aggressive, I know. So the planning process started on the 30th of July, which is roughly 30 days after I started this role as dean. My goal is to have the plan complete by October 1st of next year. And the intention is to give ourselves roughly 9 years towards the year 2030, where we can implement what we're calling the Cornell Engineering 2030 vision that gets us back to that place where we're not just influential and impactful in our own eyes, but we're influential and impactful in the eyes of the world. So I look forward to hearing your thoughts on this in the Q&A. Next slide, please. So one of the big new tools that I feel quite fortunate to have as your dean is this idea of big ideas, right? So our Alumni Affairs and Development team came up with this concept as a way of bridging the silos that exist within Cornell, right? Chemical engineering develops the best people in chemical engineering and has no interest, at least historically, in thinking about how these persons might, in fact, interact with persons in ag. This is changing in part to our development, in part thanks to our development folks who have basically challenged the colleges, challenged the departments to think outside of their silos, to think about how do you develop big ideas that can change the world, that leverages expertise, not just in your own unit, but across units to have impact. And so as an example, right, the engineering leadership program, Cornell engineering undergraduate students have this unique opportunity that started with a seed for developing leadership training. This is something I know many of you learned on the job and wish you did while you were students here. We're not attempting to teach students everything there is to know about leadership. I mean, much of that is, as you would agree, is gotten by experience. What we're doing is teaching students the ingredients in becoming good leaders, preparing them to work in complicated teams, preparing them to solve problems that requires conflict resolution and so forth. Things that sometimes you need an MBA to figure out. We are teaching our students that from day one in the College of Engineering. That is a big idea because it has the opportunity to create a new type of engineering graduate that is in fact ready to take on problems in the real world. Commercialization. I started by saying that historically, the modern researcher's success was judged by the impact of their teaching, the impact of their science, their research. But increasingly, that impact requires taking the best research into the world, into products, into companies that have commercial impact. The Commercialization Fellows Program in the college is a big idea because it allows us to do that, not just in Cornell, in Ithaca, but across campuses, in Cornell, in New York City, in Cornell Tech, in the College of Agriculture and Life Sciences, and so forth. We've developed institutes for quantum information systems, space technology, integrated product design and manufacturing that I'm happy to talk about, data sciences and AI and energy systems that are all, driven by this notion that big ideas don't happen by just one unit leveraging its expertise, but by a unit partnering with others where their complementary expertise to solve a problem that's important to humanity. So again, I look forward to partnering with any of you who are interested in helping us identify these big ideas, identify problems that you see as important in the world, so we can galvanize the talent we've got across the campus here, so we can begin to not just do cool things in research and teaching, but things that impact the world. So the next slide talks about the fundraising opportunities and priorities that we've already identified that will allow us, if you will, to actionize some of the things that I've said as aspirational, right? So faculty and research excellence, we need to hire the best people. One of the things that I feel is tremendously impactful in hiring is when you're able to hire persons who are not just excellent at research and teaching, but are also leaders. Persons who can come to campus and create multi-investigator centers that then basically galvanizes a community to work on a problem of bigger interest or potentially bigger impact. I see those persons as also giving us an opportunity to change culture by their example. This is an area that I need your help in terms of investment. Teaching excellence, I've already pointed out to you that we do far too little to reward faculty members for excellence in teaching. I think the McCormick Teaching Excellence Institute is a beautiful example of what a small investment can do to transform the culture and climate for teaching in the college. I want to do more of that in my time here as your dean. Supporting students, the Cornell Promise Scholarships, graduate fellowships. These are ways, I think, to make students not see the cost of coming to Cornell as a barrier to getting the top-rate education we provide. And I think this fundamentally has allowed us to be diverse at the undergrad level, and it's something that I'd like to leverage to create greater diversity at the grad level and ultimately at the faculty level. Spaces such as the transformation that happened in chemical engineering didn't happen overnight. That happened because our alumnus, Sam Fleming and his family, saw it as a priority to invest in this old building, to bring it into the modern world. There are opportunities like that I'd love to interact with you guys on if you're interested in pretty much every building across our engineering quad that would modernize the buildings, would transform our ability to do cutting edge scientific research. I mentioned living laboratories. That is an ongoing need. The project teams is another related to student support, building opportunities between colleges. And so I want to stop there because I want this to be more about your questions. Next slide, please. I want this to be more about your questions and my ability to configure these aspirations, these early thoughts about the direction in which we want to take the College of Engineering, and to do that in partnership with you, our friends. All right, so I look forward to spending the next 30 minutes or so with this group, fielding your questions, and hopefully engaging in a lively conversation about the aspirations, goals, opportunities that we've identified for our college. So thank you.
Thanks, Lyndon. So I will help moderate the question and answer portion of the day. I'm Carol Packard. I'm the Associate Dean for Alumni Affairs and Development. My apologies for being late, and you might hear my children in the background, so my apologies for that as well. We have a question in the chat that says, can Dean Archer elaborate on the living laboratories?
Yeah, so the living laboratory is something that everyone says they do, right? So this has become the newest thing, right? Everyone is doing a living laboratory. But the living laboratory at Cornell is a really interesting partnership between our facilities people, the faculty, and students. And I would argue the best way to describe it is by giving you the best example, which is the so-called Lake Source Cooling Project. I don't know how many of you remember that project, where we had this interesting idea of using the cold water from Cayuga Lake to cool the campus. And this, of course, was controversial at the time, but smart people said, why? My goodness, if we do this, it provides a really interesting way to sustainably cool the campus. And guess what? We did it. It came in under budget, and it continues to cool the campus to today. So that was a beautiful example of how the campus could be an example for the world in how to cool buildings sustainably. The reopening of the campus, I would argue, is perhaps the most successful living lab concept, right? The entire country is trying to figure out, how do we get back to work in a time of a pandemic? How do we, do the testing at scale? How often do we need to do it? How do we do the contact tracing? How do we, teach students who are wanting to have fun, but at the same time understand their responsibility to each other? Well, how did our university do it? Well, we went to data science. And the first thing that came out of that analysis was whether we opened the campus or not for in-person instruction, students were going to come back to Ithaca. And that led to this very ambitious program of testing, contact tracing, that has been just tremendously successful. In fact, if you look at the dashboard today, it is just remarkable that we have, 14 cases in a campus that has over 3,000 students, faculty, and staff. And so again, I think that is a living lab, because it now tells the world, not that you're identical to Ithaca and you do exactly what we do, but it tells you how you can combine data science, analysis, contact tracing, and financial planning to solve this big challenge for all of us. So I can go on, but hopefully that gives you a perspective why I'm excited about this. It's where we can use our campus to define opportunities that solve big problems for the rest of humanity.
Thanks, Lyndon. There's a couple more questions in the chat. From Ron Pitt, the college has done extremely well in recruiting a diverse student population. Congratulations. Having spent most of my career working with first-gen students, what is engineering doing to support first-generation students to help ensure their success?
It's a great question, and it's the challenge I've set myself, actually. I think it's great to say we've got good diversity numbers, but I think it's actually more important to be able to say that, whatever the mix of the students who come to school here, they thrive, while they're here, and they thrive even more after they leave, right? And the question obviously is, how do you do that, right? So we do that here by rigor. We still are committed to providing a rigorous engineering education that's centered around problem solving. So it doesn't matter where you come from or what you look like, if I can put it quite that way. The product of this experience is a student that is a problem solver. And to the extent we're successful in doing that problem solving training across demographic areas, we create students who can succeed and excel in the workplace, as you have. Now, what we do, though, is we don't stop there, right? So we overlay on top of that things like leadership training that I talked about earlier, project teams where students get to interact in a context that's similar to what they might experience in the real world. And making our faculty aware that these students, they come here and it's our responsibility to ensure that they receive a rigorous Cornell education in the process. So again, I can go into a lot more detail, but the thought is that we recruit bright students, and that's a good place to start. We educate them rigorously, which is important, but we also provide an overlay that anticipates engineering practice, communications, leadership, and so forth, that I think puts these students from whatever demographic group, first gen and so forth, at an advantage when they leave Cornell. Great question.
Thanks, Lyndon. Let's see, I'm going to combine two questions. Debbie Reiflin, and bear with me, folks. Another individual, I will get there, are asking about the rankings, basically. And, Cornell's overall rankings have declined as well since 1990. Is there a shared interest, and I'm assuming that means across the institution, and in reversing that trend? And if so, what measures are being taken across the university, not just in engineering, in order to address that?
Well, so remember, I'm a new dean, so I can't speak for the whole institution. So why don't I speak about engineering? And in some sense, this is intentional, because my goal is, by paying attention to rankings, to reverse them. I think, as you are probably aware, there's a tendency when things aren't going well to just kind of hide from them, right? To say, oh, we're better than that ranking, so why even bother with it? But I don't believe that. I think it tells you something that behooves you, behooves the college, behooves the dean to understand why we're slipping. And I've done that. So I've looked at the data and I've spent a lot of time thinking about why. And it turns out that we kind of know why we're slipping. We're slipping in part because our research activity is lower than our competition. And as an example of what I mean, the average faculty member at Cornell, in Cornell Engineering, spends about $580,000 a year supporting research programs. The average faculty member at University of California, Berkeley spends about $890,000 a year in supporting research programs. At Carnegie Mellon, that number is $700,000 a year. And that is not everything, right? The amount of money you spend doesn't necessarily correlate with your impact. But if someone is spending $1 million per year per faculty, and you're spending half that, and they're recruiting from the same pool of faculty that you are, ultimately, it's just a question of time before they begin to have greater impacts in terms of the research discoveries than you have. So knowing that is what in fact inspires me to pursue the first two opportunities on my list, right? The first one was about rewarding excellence, right? So within the average, there are faculty members in the College of Engineering who are in fact raising 1 million plus per year in their enterprises and research. They're competitive with the faculty members at MIT and anywhere else. We've got to reward those people. We've got to make it clear that these are the kinds of activities that we want to encourage. Likewise, there's an opportunity in terms of who we recruit. If we were able to recruit persons who are working in fields that are exciting, persons who are doing research that's at the frontier, it's one way to reverse these trends and to become even stronger. So these are the kinds of investments I think we can make, and inspired again by data, that I think could allow us to have the impact as a college. And the thought is that if we are successful, this is the kind of thing that you could begin to deploy on a broader university level.
Thank you. So this is somewhat related, but just a little bit of a different question related to from Anne Von Lehman. The drive to multidisciplinary work is a major trend right now. However, world impacting invention often comes from fundamental research, which you pointed to.
Correct.
What is your vision for balancing both the need to be interdisciplinary while also thinking about fundamental research and its importance to the academy?
These are very astute questions. Yes. So I don't think they're mutually exclusive. In fact, I was trained as a polymer scientist, as a card-carrying chemical engineer. If you look at the work I do, and the work that's been most impactful, you would think I'm a material scientist. Why? Because I was trained well. I was trained so I can leverage the molecular skills of the chemical engineer to solve problems that are relevant in a different field. And so I believe that, if you recruit people who are fundamental, but they sit at the intersection between fields so they can kind of see across the boundaries, I think that is always the way to solve fundamental questions in a way that's interdisciplinary and that is impactful. I mean, obviously, it's not the only way. You have to also complement hiring at interfaces with hiring in the core, because one has to teach the core. And so part of my strategy as dean is to do exactly that, to hire persons in the core of our disciplines, but to also emphasize senior people working at the intersection between the disciplines, to not compromise rigor for cross-disciplinary work, but then to complement that with hiring and rewarding excellence in teaching. So we don't just lose track of what I think is a signature strength of Cornell, or excellence in teaching, as we chase down the aspiration of being recognized as the best in the country, or probably among the best in the world in research.
This one is a total departure. Do we have a project to store, from Joshua Goldberg, do we have a project to store energy from wind and solar sources? And he notes that renewable energy without storage is not as useful.
Yeah, so Josh is forcing me to talk technical today. I'm trying my best to just, so that's my field, Josh. So my field is energy storage and batteries. And again, as a chemical engineer, I saw an opportunity to create batteries that are extremely low cost and scalable. And one of the big successes we've had in my group, and there's a very nice paper in Science that was published last year from my group that reports this success, is that we've created a zinc battery, right? Zinc is a throwaway material that uses water as the electrolyte. And this battery can actually cycle 10,000 times. And what it means is that if you now look at the amortized cost of that battery, it is comparable to the 2-3 cents a kilowatt hour that we need to store renewable energy competitively with energy created from fossil fuels. So that is just one dimension to the problem. So there's exciting work going on in intrinsically low-cost batteries that use earth-abundant materials like zinc, aluminum, and so forth to create high-energy storage. But there's also very interesting work based on solar thermal storage, where we use phase change materials to store excess heat in times when we've got a lot of sunshine, to ultimately use that heat when the demand for heat is high in the winter. You can argue that the Earth Source Heat Project is probably the best example of that, where we're using heat that was actually in fact generated from the time the Earth was made, from the Big Bang, to provide heat for the campus by drilling down deep enough so we can exchange heat from the Earth with water and use that water to warm our buildings. So there's lots of activity in this domain, and you're absolutely right that it's an important complement to the excitement that we see in renewable energy generation.
Thank you, Lyndon. These are two related but different questions, so I will combine them. And hopefully Matthew Sagel and Alan Rosenthal don't mind. Matthew asks, does the establishment of life science programs in multiple departments create the silos that you are trying to overcome? These overlapping departments are in engineering as well as in ag and chemistry, as an example. And Alan asks, relatedly, are we developing well-rounded students with some background in humanities as well as in technology?
Yeah. Well, this is two hard questions, right? So I would argue that our decision more than a decade ago to create the biomedical engineering department was probably one of the best things the College of Engineering has done in a long time. We created this department at a time when I think the conventional wisdom might have said, don't. That we obviously had a bioengineering program in CALS, but there was a wisdom there that said, there's a future of medical technology that is going to require engineers who aren't just, making widgets, but engineers who understand the deep biology, that they can make widgets that actually matter, that can be deployed in the body and so forth. And we did it. And frankly, it's one of the more successful departments in our college. They hire superstar faculty who have backgrounds often in physics, biology, engineering, mechanical engineering. And it's just wonderful how they've, leveraged fundamentals of engineering to create opportunities that impact medicine. So you are right in the sense that left unchecked, that can be its own silo. But what we're doing is better. So we are now working in this sort of one Cornell engineering umbrella that I mentioned before to create real bridges to Weill Cornell College of Medicine. I would ideally like to see a collaboration with Weill Cornell, where some of our biomedical engineering faculty are in fact resident in New York City at Weill, that rubs shoulders with the medical doctors, the surgeons, and so forth, and brings back problems into the classroom that the students work on that are relevant to human health and human well-being. So silos are a risk. They're dangerous, but I think with the right kind of proactive leadership and the right kind of proactive mechanisms to integrate across those silos, I think they can be quite successful, as in this context. Now, the humanities, that's a really important question. We continue to do what you probably did when you were a student here, which is to require students to take courses outside the college in the humanities. But what has been built up in the college, I would say in the last couple of decades, is a tremendous program in ethics, in communications. I mentioned teaching, in leadership, right? Where within the college, we are in fact attracting students from outside the college to take these programs that round them out. And I want to do more of that. In fact, I see no reason why every single student on a campus like Cornell shouldn't take a course taught by engineers on data sciences, because it's important to someone who's doing sociology, psychology, maybe even art and planning. I've heard recently a similar aspiration about artificial intelligence. It's the future. Why shouldn't engineers be teaching courses that in some sense does the reverse to what we've done historically, where we've gone outside to become rounded out? I think there's now an opportunity for us to add value to diverse students from across the Cornell campus by teaching engineering at a level that these students can now integrate in their own experience to improve their impacts in the job market.
Thanks, Lyndon. I work, so Sheldon Marr asks or says, I work for an engineering firm that greatly values diversity. It's great to hear that Cornell's engineering's incoming class is more diverse than most. Are there any initiatives that the college is taking to build on that success and further improve representation among underrepresented minorities? There's quite a lot that you could point to.
Yeah, there's a lot. There's a lot. So maybe I need to write you several paragraphs. But there is a lot. And I think, we've learned, I would argue that we've learned how to do this better with every incoming class of students. And just to give you a little bit of context, so I used to teach until last semester fluid mechanics, which is probably the most mathematical course in chemical engineering. And I taught that course to sophomores. So I got to see very quickly, the deficiencies of students from across the spectrum. And what it's taught me is that there are really important opportunities for partnering with the high school students come from, sort of ahead of the time they get here. Very bright students, but just that they were not exposed to the complicated calculus and so forth as some of the other students we recruit. And I solved that problem by basically making my course self-contained, by teaching students the skills they need to solve the problems I want them to solve. I think I can get even further with these students if we partner with their high schools ahead of time to provide the tools that they all come here pretty much equally prepared. So that's one place I think where we can do better to strengthen the cohort of students we recruit. The second place I think where we have a really important opportunity is a kind of internship opportunity as we provide these students while they're here, right? So increasingly students are not going to co-op, and we don't quite understand why. They're choosing to do internships. And for those of you who've forgotten, right, the co-op is a 2-semester commitment from the student. And typically to graduate on time, the student then stays for 1 summer in Ithaca, taking courses they would have perhaps taken in the fall. The internship is a once summer opportunity. And what we're finding increasingly is students like internships because of the diversity, right? They can go to 2 different companies in their time here. And the challenge I see, or the opportunity I see for underrepresented students, is that we need to expose them broadly to internships at companies that in fact have a vacuum that needs that talent. And this is something my associate dean, who's not here, for undergraduate affairs for diversity, in academic affairs, can speak to in volumes. We have a very nice program that we just started with AT&T Bell Labs that is now Lucent, where we're going to be sending something of order 30 students a year to Bell Labs to do internships. And I think that if we can do that consistently year over year, and if we can do that in tandem with the partnerships I talked about with their high school teachers, I think we're in pretty good shape for creating students who thrive here. And ultimately, I think that's a virtuous cycle, right? Those students then recommend people they meet to come to Cornell, because we don't just teach you engineering, we give you skills that ultimately make you more successful. So short answer, I think, but really something that we've spent a lot of time thinking about, and there are even more opportunities to develop better.
I think we have time for one more question, Lyndon, and I want to thank everyone so much for your time and attention today. It's been great to have all of you with us. And this one is quite timely in terms of how we've had to approach education, through this hybrid model during the pandemic. From Bob Blau, given the economics of providing education, will Cornell push to more large online classes with excellent experienced lecturers? I'm assuming he means in the future, or will we continue with some sort of hybrid model? If you wouldn't mind sharing your thoughts on that.
Yeah, well, that's the big question, right? That's the $1 million question that all education is facing today. I feel a sense of responsibility that this education, whether we do it online or in person, has to be a Cornell quality education. And so I'm not necessarily interested in just, keeping up with the Joneses to do this. The question is, is there an opportunity for Cornell Engineering to teach students at a distance? And how do we do it in a way that maximizes quality and impact? And I see two opportunities, two big ones. I see one at the beginning of the experience at the freshman level. I think that there's an opportunity to perhaps grow the College of Engineering by about 20% in terms of the number of students by having 20% of the freshman class on a volunteer basis choose online instruction for the freshman year. And the thought is that if we did that at some reasonable discounted rate, it gives us an opportunity to avoid the sort of congestion that happens by the university's commitment to housing all freshmen on campus, and gives the college a chance to educate more students. So that at that end of the spectrum, I think there's a real opportunity for educating students in a distance learning configuration. At the other end of the spectrum, that is a student who in fact can't come back to campus, right? The student who's working, the person who would maybe do an MBA or a master's in project management. I want to create distance learning opportunities to teach students at the master's level where they live and where they work. And this is an opportunity that we have some experience with in systems engineering. We've done that for at least the last 8 years and done it extremely well with companies like Lockheed Martin using us as their exclusive place to educate master's students in systems engineering. I would like to do that across the college. I have a vision that someday, if we do this right, we can have it so that the master's degree in engineering feels functionally like an MBA, where the student feel like there's enough value that's been added to their education, enough of a bending of their career trajectory that occurs as a result of that value, that this becomes prestigious degree to have. So more to come. I'm only in my 4th month, so not too many things done yet, but these are just a few of the concepts that my colleagues, I think, have largely galvanized around and are excited about. But deans don't get to make big decisions like that, right? It has to filter up to the president and so forth. And we're undergoing that process almost as we speak.
So I want to end on just one nice compliment that might embarrass you a touch, Lyndon, but it'll be a nice way to end the conversation today. One of our colleagues shares, Dean Archer is clearly an excellent choice to be the Dean of the Engineering College. So I would like to thank you for taking the time today, Lyndon, to speak with everyone. I think that everyone on the call has really enjoyed it.
Well, thank you. No, thanks. I know some of you have seen me speak before, or heard me speak before on these very topics, and I hope I didn't bore you. I try to change it every time, but there's just a finite number of things that you can say in terms of your vision and goals and so on. But hopefully, you've come away from these interactions knowing two things about me. One is that I'm motivated to excellence. And two is that I prefer to do than to speak. And I hope that the next time we see each other, hopefully in person, I'll be able to give you updates on, how our strategic planning activity has gone, how our initial hirings have shaped out, and hopefully to give you some good news that the initial investments we've made in strengthening the productivity in terms of research from our faculty are beginning to have impact on the rankings and the perception from outside of Cornell. So again, I appreciate the time you've spent. I'm an open book, so send me email, send Carol email if you want to follow up on any of the things from today, and I look forward to speaking to you in the future. So take care and stay well.